Sales manager here. You'll also hear kind of behind the camera here, Dave Fisk, who works with us on the sales side of things as well. But Brasch is a family-run manufacturer of gas detection systems. We've been manufacturing gas detection for over 25 years now, and our primary focus in the gas detection realm is vehicle emissions, and specifically carbon monoxide and nitrogen dioxide, looking at applications where you have vehicles or exhaust inside of enclosed facilities. So this could be anywhere from a firehouse, a car dealership, vehicle repair shop, parking garages, distribution centers are a big one right now that we get into. And specifically today, I want to kind of walk through, as you're looking at these particular projects, how to lay out a gas detection system. What is the adequate coverage for the sensor? What is the recommended mounting height for different gases within a particular facility? Kind of walk through some of that, and then take you over to kind of our products, kind of do a live demonstration here with some of our equipment, pointing out just a few things that we do differently than some of the other manufacturers. I'll say, generally speaking, there's a dozen gas detection manufacturers out there, and for the most part, all of the systems function in a pretty similar fashion. You're going to have a sensor that's detecting the gas. It's sending that signal back to some type of a controller that's then going to turn on your ventilation equipment, open up a damper or louver to begin ventilating out the facility to keep those gases under a harmful level. So quickly here, I'm going to kick over to a couple documents that I have that I want to walk through. So the first thing that I want to talk about here is the coverage area that each individual sensor offers. So both our carbon monoxide and our nitrogen dioxide sensor, we say on average cover about 7,500 square feet with a 50-foot radius of coverage. Now you can see here in this particular drawing, relative to the scale of the specification or the drawing there, we just create a 50-foot radius of what that sensor coverage would be. And then kind of factoring in your ability to mount these within a facility, you take those and essentially just plop them onto your drawing to give you coverage of that entire area. Now, you may notice that in a few of these sections, there are a few small gaps in between some of the circles, as well as a few spots where you have some overlap. And with these sensors and with the air that's moving through these facilities, it doesn't have to be a complete full coverage of every single individual sensor overlapping. And a big factor that plays into that particularly is where you can mount these within a facility. So particularly in a parking garage, when you have pillars that are maybe every 10 to 20 feet, it's pretty easy to be able to just mark those on the pillars throughout the facility. Whereas if you have a facility that doesn't have anywhere in the middle to mount, you then have to look to the exterior on the walls to mount those sensors. And if you were to do that and move those sensors over, you're effectively taking your coverage area and cutting that in half. You're taking that half circle and it would get pinned up against the wall there. Now, particularly in facilities where you may see some of this application, we work with that job specifically depending on the height of the ceiling, but you can mount those at the ceiling to still be able to get coverage in a larger area where maybe the exterior walls are still several hundred feet long, and not being able to reach into the middle of there. Now, along with just the individual spacing of the sensor, another very frequently discussed topic in gas detection is what mounting height these sensors are recommended at, particularly the nitrogen dioxide. So it's a pretty standard industry, or I say industry standard, that carbon monoxide gets mounted at about 5 to 7 feet in the air. That gas, just from the density of it relative to air, is going to just stay right there in that breathing height. Now, nitrogen dioxide particularly when that exhaust comes out of a vehicle and it's heated up, the gas is lighter than air, and it's going to rise up to the ceiling in the facility. Now, particularly, this is where some manufacturers have different recommendations on where to mount. Honeywell is particularly one of those where they actually don't even offer a dual sensor that you can mount at 5 to 7 feet. They recommend every single time for that NO2 to be mounted at about 2 to 4 feet below the ceiling. Now, our take on this particularly is it's entirely dependent on the application and what type of vehicles you're going to have going inside of the facility. So particularly if you're looking at something of a firehouse, as you can see over here on the left, generally speaking, in those applications, you're not dealing with some type of a large stack exhaust. So when that exhaust comes out of the vehicle and it's only maybe 3 or 4 feet above the ground, as that gas rises, it has to pass through 5 to 7 feet well before it gets all the way up to the ceiling. And so in that scenario, that's where we recommend the NO2 being mounted at 5 to 7 feet, because you're going to detect the gas in that range faster than you would having it be all the way up at the ceiling. Now, on the flip side of that, when there's applications where you know that you're dealing with larger vehicles and stack exhausts that may, the exhaust might be coming out at 10 feet already. And in those scenarios, that's where we recommend mounting right below the ceiling. And that's when you're going to catch that gas at its earliest point. Before then, it cools down and falls back down to what would be the normal breathing height of a facility. Now, from a kind of a sequence of operation and a specification standpoint, you can see here, and I'll show you in just a few minutes here, where some of this information is located on our website. But this is 2 separate examples of our particular system. One being the standalone detector on the left side for your smaller application, and one being a control panel over here off to the right. And what these documents are is it's basically a walkthrough of all of the sequence of operation of the system itself. So one thing that Brasch particularly does that's a little bit different than some of the manufacturers that are out there is that everything that we put together for a project, we pre-program, we pre-address, we pre-wire the entire system before it goes out the door. So as you can see here in the specification, we specifically have low alert, high alert, and alarm set points that are configured into there so that when that product gets put into the specification, all of those parameters are pre-built into the system, that when it gets shipped out to the customer, all of that stuff is already pre-configured and ready to go in the field. Again, this is a document you can see here that has some implementation into it in terms of a number of sensors that are on the facility, as well as some of the fan sequence of operation. And as I kick back to our live demonstration, I'll touch into some of the more customization that this provides. But this is a very common document that we see getting implemented into gas detection applications. So generally, you'll see a pairing of a layout, as you saw on the first page, along with a document very similar to this that gets put into the specifications. Now, as I kind of walk through and show you how to do this on your own, something that Brasch does provide is all of this service in-house. So we go through gas detection projects on a daily basis. We put together layouts, we put together specifications and wiring diagrams that you can take and plug directly into there as well. So certainly, anytime that you're going through a project, never hesitate to reach out to us here directly. All right, I'm going to kick back over here to our demo board. So one of the biggest factors with picking out a system for a facility ultimately comes down to the size of the facility itself and how many sensors it is you're going to need. So as I mentioned before, you're going to see some smaller application projects like a firehouse a car dealership that may be 10 to 15,000 square feet of coverage. And that's where we have our standalone detector that can monitor up to 4 sensors. So if you're detecting CO and NO2, you're looking at up to about 15,000 square feet of coverage. Then our control panel, when you get into larger parking garage applications, distribution centers, Amazon, FedEx, UPS, the control panel can monitor up to 128 sensors. So looking at dual gas coverage, you're just under 500,000 square feet that one single control panel is able to accommodate. So there's really a full range in terms of the application. And ultimately, it just comes down to how many sensors it is that you're going to need in that facility. Now, as I talked before about the sequence of operations of the detectors, both our standalone and our control panel have built-in controls that are designed to control the ventilation equipment within the facility. Now, we do offer a building management system transmitter that is just an individual sensor that simply sends a gas value back to a building management system. So there's no controls and no fan functions built into here. You're simply sending the signal back to a building management system, where then the building management system would be able to turn on your ventilation equipment and control whatever else might be in the facility there. Now, generally speaking, from a design standpoint, your building management system might not be in the most ideal location relative to where some of your fans are, or if you're looking at a multi-floor parking garage. And that's where our standalone and control panel come in. That majority of the time, from a design standpoint, the gas detection will be controlling the ventilation. And then in the event that there is a building management system that wants to take, be able to monitor that, you can have Modbus and BACnet outputs that you can connect into those building management systems. Now, our particular units here are set at a pretty, I'll say, kind of a UL and an OSHA standard in terms of our factory defaults and the sequence of operation and how they're designed to control the fans to keep gas at a certain level. And I'll show you a document when I kick over here to the website that kind of points out some of those regulatory things that are on there as well. But our standalone detector is designed around a 3-relay sequence of operation. Generally, in these smaller application jobs, you're going to see either a 2-speed fan or maybe just an individual single fan that you have tied into your detector. Sometimes you may have a second fan, and so you can have a low alert and a high alert to control 2 different fans, or a 2-speed fan if that's what they're looking at. Then you have a high alert value, or an alarm, I should say, that is designed to tie into like a remote horn and strobe, maybe a fire protection system that's already in place. And that's to say relay 1 and relay 2 did not flush the gas out fast enough that the gas levels continue to rise, and that's when your alarm would go off. So as you can see kind of on our display fixture here, we have a first fan and then a second fan that are configured on our standalone unit. Now, you can activate those obviously by the sensors detecting gas. You can also have just simply from a manual override that you can hit to turn those fans on within the facility. But generally what you'll see is that you'll have the fan, the gas hit a certain level. For us, our factory defaults for carbon monoxide are 35 for the low alert and 100 parts per million on the high alert. So you would see that first fan kick on when your gas level is above 35. If that were to continue to rise and reach above 100, that's when your secondary fan would kick on. And then, as I mentioned before, if those fans are not flushing the gas out to a capacity that they need, that's when your alarm would go off. There's an internal buzzer inside of the standalone, as well as anything else that you may tie into that alarm dry contact. Now, as I referenced, this is a kind of a very simple and very straightforward. There's low alert, high alert, and alarm. we do see a lot of applications where there is a lot more sophisticated sequence of operations. You may have several different zones or floors of a parking garage that you're working with, as well as multiple different set points. We deal with Amazon and their distribution centers, and they particularly like set points of 12, 25, 75, and 100. So those are 4 different set points right there that they spread across multiple different zones, controlling multiple different sets of ventilation equipment. So our control panel, you can take up to 32 dry contact relays across 32 different zones. And so there really isn't, as I would say, a flat sequence of operation, because it was designed around being able to have that full customization. If you just want one relay on one fan, you can do that. In Amazon's case, if you want 4 different fans across 4 different zones using 16 dry contact relays, you're able to do that as well with the control panel. Now, as I talk about kind of the sequence of operation and some of the zoning capabilities that are available with that control panel, one of the other big things that gets talked about from a design and installation standpoint with gas detection is when you're mounting these, what is the most economical way to wire in your ventilation equipment, as well as tying your sensors back into your control panel. So all of our systems are run off of a RS-485 communication, and they run in a daisy chain fashion back to the control panel itself. Now, one particular thing that we wanted to incorporate with the control panel from an installation side was the ability to take the relays and mount them remotely from the control panel. So as you can see on the inside of our panel here, we have a circuit board that has 4 dry contact relays on it. That board is what we call, we put actually in a remote box that's over here to the side, and we call that our expansion pack. And again, it's the same board that you have inside the panel there, but it allows you to take these dry contact relays, mount that expansion pack directly next to where your fans are within a facility. And then you simply just have to daisy chain that expansion pack right into the sensor that's closest to that on that particular floor. So instead of running, you have a 5th floor on a parking garage, instead of running your fans from the 5th floor all the way back to a maintenance room where you have your control panel, you take that and mount it right next to it. And then as you daisy chain that expansion pack in, there's actually a repeater or a booster that's built in, designed to cut down on any interference that you may have as you have thousands of feet of wire running within these facilities. And then as a kind of added feature that we put on that expansion pack, there's also an analog output. So if you're looking to hook into maybe a VFD or a building management system, you can take a single analog output, and depending on how many sensors it is you have configured onto these relays, you can take an average of 10 sensors. You can take an individual sensor, but it gives you the ability to take multiple readings and have one signal that goes back to that VFD itself. Now, as I say that, every one of our individual sensors has its own analog output that comes standard on the equipment. But again, having that expansion pack analog output gives you the ability to, again, reduce the wiring as you're looking to do the installation on these systems. Now, that remote expansion relay module is something that there's a few other manufacturers that take a similar approach to it. Acme is one of them. They have a remote relay module, a remote analog output, and a remote repeater. They're all individual products that all have to individually be wired in. Each one of those they have retailing at over $600, whereas we have one individual expansion pack that serves multiple purposes that we have in the market at about $600 itself. So it's something that really allows you to be able to expand your system into larger applications while still being able to reduce a lot of the cost that may be associated with some of the other systems that are out there on the market. Now, particularly, as I referenced before, the mounting height within a facility. One thing that we do that's a little bit different than some of the other manufacturers is having dual sensors. Now, as I mentioned before, Honeywell is particularly one that doesn't offer a dual sensor, but it's something that we truly feel very confident in. And there is a few other manufacturers that have dual sensors as well. And you'll see here with our standalone detector, I would say probably 90% of the time, when you're dealing with vehicle emissions, you're looking at a combination of CO and NO2 within a facility. And so that's where you're going to have two sensors that are inside of one housing that allows you to be able to monitor both gases without running wiring up to a second unit that may be up at the ceiling. Now, taking that a step further, not many manufacturers, to my knowledge, I'm not sure others that are with a standalone unit, allow 4 sensors on one standalone. So a few manufacturers you can have a third remote sensor. However, as I said before, generally in vehicle emissions, you're dealing with CO and NO2 as part of the application, and that third sensor doesn't get you both gases. So part of what we offer with our standalone unit is that you can have 2 internal sensors as well as 2 remote sensors that can tie back into that standalone unit. We see that both from a raw material cost, because you don't have to purchase the controls functioning twice, but also from an installation. You don't have to bring your fan wiring into 2 separate spots and then parallel those dry contacts together. You simply just add an extra sensor and tie that back into your standalone unit. And we see this across the board within the industry, about a 15 to 20% savings, depending on who the other manufacturer might be. And so as we look at applications of firehouses and vehicle repair shops and car washes, this is really an ideal product to be able to accommodate all of that in a very cost-effective manner. Now, as I mentioned, kind of car wash type applications, another thing that gets brought up frequently is kind of water durability to these particular units. And so I'll touch on here kind of some of the aesthetics and the build of the units themselves. One thing that Brasch takes a lot of pride in is that all of our products are made here in the US. We manufacture out of St. Louis, Missouri, and we deal with a handful of local suppliers, from metal fabrication to polycarbonate enclosures, printed circuit boards across the board. And we really feel confident in the quality that provides, as well as in today's market from a supply chain standpoint, we're able to ship products out within a couple of days. So I just talked with somebody yesterday. He said, hey, we have an inspection on Friday. We need a panel and 11 sensors, and we're putting it together. It's going out tomorrow, and they'll have it there upon us inspection. And relative to some of the other manufacturers in the industry, we hear 4 to 6 month lead times, depending on who that may be. And so we really do take a lot of pride in that, being a family-run manufacturer, products made in the US, certainly something we stand behind firmly. But our standalone detector comes standard as a NEMA 3R enclosure. And as I say that, I'll kind of preface all of our features that we offer within our equipment comes as a standard. So we really like to take a simplified approach in terms of the number of part numbers and what all comes with those particular parts, rather than having to add a letter or a number for a NEMA rating or a back net or a touch screen. Those things all we factor in as a standard within our systems. So the standalone is a NEMA 3R enclosure. It has rain tight conduit fittings on the top. There's vented louvers that are on the side there. And for any condensation or moisture that may get into the unit itself, there are drain holes that are designed in the back of here that kind of run along the back panel plate that is able to accommodate anything that may get into the unit itself. But with the louvers and things on the side, and not having front facing sensors is something that really plays a big factor. And you'll see some of the, actually quite a few manufacturers have their sensing elements that are directly on the front of the unit with some vents that allow the air to get through there. And as you can imagine, whether it be a car wash or somebody that's just spraying down a vehicle, that allows for water to get in a lot easier than it would just simply from draining down the side. And again, that's what those louvers there are designed to be able to accommodate. Now, the reason that it's a NEMA 3R and not a NEMA 4X is that you do have those internal sensors in there. So there still does have to be air that moves in there in order for you to be able to detect the gas. Whereas our control panel, without there being any internal sensors in here, our control panel comes standard as a NEMA 4X enclosure. So the NEMA 4X, it has a steel welded plate across the front of here. As you can see, it's a 7-inch full color touchscreen interface and comes standard with Modbus, MSTP, and BACnet IP for your building management system applications as well. Now, I won't kind of go down the rabbit hole too much here, but the touchscreen itself, you'll see as I click on here, you can visually see all of the settings that are available within this unit. So you'll see what the sensors are reading, what the gas type is, what the activation type is. But as you can see, when I click on things here, you are not allowed to go in and make any adjustments to the unit itself. So as this is, sitting in a parking garage or in a facility, nobody has access to come up here and do any of that. However, when you go into your settings here, it's going to ask you for a passcode that allows you to be able to go in and make some of the accommodations that you may want to do in the field. Again, we send it out factory programmed, so that's generally not happening in the field, but there are times where somebody wants to change what the activation level is, maybe add a sensor or two as things go on within a facility. And one of the things that we get an incredibly good feedback from contractors and those in the field is just the simplicity of being able to operate a touchscreen. And when you're looking at facilities that have, 100 sensors in them, you have 16 relays, 4 different zones, all these different set points, each individual sensor has to be addressed. Each individual zone and relay has to be configured on other manufacturers' equipment, let alone it's not being done on a touch screen. So you're seeing equipment that's a control panel and it has an up and a down, a left and a right arrow that makes it very, very cumbersome to go in and do that. So just the user interface that a touch screen provides with some of the complexity that could potentially come within these systems is something that differentiates our controller a little bit from some of the competition that's out there particularly. I want to go kick over now to the website and show you where some of the information is that we have on there, as well as all of our CAD drawings and specifications as you kind of are moving forward and potentially looking at, gas detection applications. So this here is the kind of homepage of the website. As you can see up at the top under the downloads, this is where you're going to find all of the technical documents for all of our equipment. So data sheets, IOMs, submittals, all of that will be available here. One thing particularly that I wanted to touch on and I referenced before was our application guide. And this just references some different terminology in terms of gas detection. As I talked a little bit, in terms of the sensors, the relays, and the zones, but also in terms of the regulatory limits that are put in place by OSHA and some of the others. So this is a very good guidelines in terms of the adequate set points that you're going to want to have within a facility. So I referenced before, our high alert set point for carbon monoxide is 100 parts per million. And our high alert on our nitrogen dioxide is 5 parts per million. So you'll see on here that 5 parts per million is a pretty common mark in terms of the nitrogen dioxide. And I would not recommend going any higher than 5 parts per million as a high alert. There have been times where we have seen projects and specifications where 10 parts per million is the high alert value. And frankly, from a nitrogen dioxide, safety level, that is too late in order to be setting off an alarm within a facility. So 5 parts per million is our recommendation on the NO2 and 100 parts per million on the carbon monoxide. Now, as you saw with, as I referenced with Amazon, they also had 12, 25, and 75. So the lower end of that spectrum is very flexible, and you can pretty much configure that however you would like, specific to that customer. But from a high alert standpoint, those are the recommendations based off of safety of the people in those facilities. You'll also see underneath it here, there's just a few technical terms, but this is also a document that gets referenced very often. So I mentioned before, our coverage area is a 50-foot radius with 7,500 square feet of coverage. You may notice that you have, depending on the ceiling height and the air change per hour that you have within a facility, that number may be a little bit less or a little bit more. And one of those applications, particularly as I talked about, is if you need to mount something on the ceiling. Well, mounting something on the ceiling is going to change the coverage area that sensor is able to provide. And you may be on the lower end of that, maybe 5,000 to 6,000 square feet. Whereas if you have a parking garage with, say a 10-foot ceiling, you could probably stretch that a little bit further and look 8,000 to 9,000 square feet within that facility. But again, 7,500 and 50-foot radius is a very safe and standard mark with our equipment, but as well as in the industry itself. I'll touch it here. All right. Another something that we have on here, particularly, is a tool that is designed to help you determine how much equipment you need within a facility. So it's allowed you to go in and enter the length and width of a facility you have to get a calculated area. If you know the area, you can just jump up here and type the area in itself. You'll put in a ceiling height. If you know your air change per hour, it will factor that in. But if you don't know that, it will also calculate without it. You'll select the gases that you're looking to monitor and a voltage, and then calculate, and it's going to recommend the system for you. So as I touched on before, a 15,000 square foot facility is perfect for our standalone detector and a pair of remote sensors. You'll see that you'll have 2 CO and 2 NO2 to be able to cover that. Underneath of this area mark, as you see multi-floor parking garages and things of that nature, you can add additional areas into here to be able to factor those floors in. And then as you calculate, it's going to jump you up to the control panel as you now have a total of 10 sensors, which surpasses the 4 sensor limit of the standalone unit itself. So again, it's just a quick way to be able to take in those parameters, determine how many sensors it is you may need, and then you can take those and apply them into the specification itself. From a design standpoint, all of our CAD drawings and specifications are listed on ARCAT. So this takes you directly here. This is where you'll see, this is our previous control panel, but all of our typical wiring diagrams, transmitter connection, fan connection, analog outputs, all of that stuff that you may need is going to be located right here, as well as the specification side of things. So this basically is just a very simple Word document that you can take and pull up. I'll hold it up here. like it's pulling up here. So then here is your just a very straightforward Word document that you can take and download, take, copy and paste, whatever it is that you may need directly off of here. And again, those two documents that I referenced before essentially are just a snippet of what that is. So as you can see off to the left here, this is documents that just got pulled directly from that specification and flowed into here. And to be honest, most of the time you're going to see applications that are very, very similar. And you'll see that essentially you'll be plugging in, like you see off here to the side, simply a number of sensors. And then as you come over here, you can plug in your sequence of operation, and then everything else will virtually stay the same. Really, that's all you're doing is extrapolating and expanding based on the number of sensors and then how much ventilation it is that you want to tie into there. So those can be created, which we have on there, and then you can take those and kind of use them in whichever application you may need. So it looks like there might be a couple questions in the chat here. So that was kind of what I wanted to touch on here today. So certainly I'll take a look at these here, but if there's any other questions that you have just in regards to our systems, but also just regulatory stuff, feel free to jump in.
So I'll read the first question from Anonymous. Thank you. OSHA standard, the question is, OSHA standard with CO health hazard is at 50 ppm. If 100 ppm is a high alarm with the CO detector, is it too late?
So it's not. And really our systems, we've had a high alert set point at, as I'm over here, at 100 parts per million for since we started manufacturing our gas detection systems. And you may notice that some of the listings that are on there have a little bit of difference between those numbers. But 100 parts per million, I believe you can have over an 8-hour period of having somebody be exposed to it. And our 100 parts per million timer is at 15 minutes. So if you stay at 100 parts per million for 15 minutes, that's when your alarm is going to close. So you don't reach anywhere near the harmful level of time that you're exposed to that gas, relative to if it was 200 parts per million, your exposure time gets dramatically reduced before there starts to be health benefits or health factors that come into play.
Okay, we've got a second question from Colin. Thank you, Colin. Is there a software you all provide to help determine how much ventilation we will need within a zone and what specific equipment can handle that?
So we don't have a particular program that's configured. With our manufacturer reps that we work with, obviously there's different ventilation equipment that can get tied into our gas detection. So across the board, whether it's a Greenhack fan, Twin City, Cook, Zoo fan, System Air, there's a variety of them, but really it kind of depends on the product itself. We do have in-house engineers. We will work specifically on a product or a project or an application with you if you have some questions in regards to that. But generally that falls more into the fan manufacturer side of things relative to the gas detection.
Okay, thank you. So Cal, we got another question. Now, what are some assumptions you all use for the air change per hour? How does your software determine that?
So yeah, well, there isn't, like I said, there isn't a configured software for the air change per hour. And that's something, I'll touch base with our electrical engineer, Brian, and see if he has, maybe some documents that reference that a little bit. Generally speaking, getting into the specifics of the air change per hour isn't something that we deal with a whole lot. It does fall, as I said, more into the fan manufacturer side of things relative to our equipment. just because it's going to be that fan and ventilation might be working for multiple other purposes, let alone for just the gas detection side of it.
Okay, thank you. And I like this question from Chris, because there's so many car dealerships out there. And his question is, which sensors do you typically see installed in a car dealership?
So ultimately, from a car dealership, generally speaking, most car dealerships we see are going to be larger than a standalone application, meaning that they're going to need, I would say, 6 or more sensors. And that's where we would use our control panel. And then you would tie our remote sensors back into that control panel. And it depends a little bit on the car dealership itself, but we've worked with a lot of high-end car dealerships as well. And there have been some applications where it may be a small room or something like that at a Porsche dealership. And they particularly have gone the route of the control panel simply based on the aesthetic of the look of the detector, because it may be on their main shop floor or somewhere that customers are able to see that, and they like the look of the touchscreen itself. But from a design coverage area standpoint, I would say 9 times out of 10, you're looking at our GDCP touch controller and remote sensors.
Sounds good. So that's the last question.